Today we are going to discuss second paper of T.Y.B.Sc, second paper real analysis. T.Y.B.Sc second paper real analysis. Real analysis first. Okay, this is a paper second of real analysis. Okay, so their first chapter is chapter first chapter is sets and function. Okay, sets and function. So sets and function. So their first theorem is if f from a to b, let f from a to b and x is a subset of a, capital X is subset of a and y is subset of a. Okay, choose capital Y, this is also set. Okay, x and y are subset of a. Okay, here given that function from a to b and x is subset of a, y is subset of a. Okay, y is also subset of a. Then image of x union y, equal to image of x union image of y. Okay, image of x union image of y, this is called image of union of two set. This is called image of union of two sets is this theorem is called image of union of two set is the union of image. Okay, in theoretically image of union of these two set is equal to union of their images. Okay, so proof of this theorem. Okay, so firstly, given condition, let function f from a to b and x is subset of a, y is subset of a. Okay, then to show here f of x union y is equal to f of x union f of y. Okay, to show here f of x union f of y. Okay, that is to show that f of x union y is subset of f of x union f of y and f of x union f of y is subset of f of x union y. When this, how to proving this equality is proving if f of this LHS is subset of RHS and RHS is subset of LHS, then both are f of x union y equal to f of x union f of y. Okay, so how to proving this these sets are subset of each other. Okay, here firstly choose elements from this set. Okay, choose take any one element. Suppose that a belongs to x, image of this set, image of union of two set f of x union y. Okay, so how to prove this theorem? here to prove that first condition, suppose that f of x union y is subset of f of x union f of y. Okay, so how to prove this condition? If choosing one element from this set, suppose take any elements from this set, suppose f of x union y, a belongs to f of a belongs to f of x union y, means image of union of two set. Okay, and then show that this a element belongs to their image of union. Okay, means to show that here a belongs to f of x union f of y. If a taking elements from f of x union y, then this showing a belongs to f of x union f of y, then f of x union y is subset of f of x union f of y. How to show here? Suppose that taking this element a belongs to f of x union y, which implies that a belongs to image of union of two set, a belongs to union of two set, then there exists suppose then there exists b belongs to x union y, then there exist any other elements such that f of b is equal to a. Okay, this element is in codomain because image of this set. Okay, here x and y are subset of a, and then their image is a subset of b, means their image is a subset of b, means codomain. Therefore this, if taking any elements from their image means codomain, then at least one element exists in domain, at least one element exists, b belongs to x union y, means at least one element x union y is a subset of a, because x and y are subset of a, then their union is also subset of a. Okay, so b belongs to x union y such that their image f of b is equal to a. Okay, f of b is equal to a, then a belongs to here b belongs to x, this b belongs to x union y, which implies that b belongs to x or b belongs to y. Okay, b belongs to x union y, which implies that b belongs to x or b belongs to y. Then b belongs to x, then f of b belongs to f of x. Okay, their images belongs to f of x or f of b belongs to f of y. Okay, which implies that f of b and f of b, here f of b belongs to f of x or f of b belongs to f of y, which implies that f of b belongs to their image, their union. F of b must be belongs to their union. Okay, and therefore value of f of b is a, and a belongs to f of x union f of y, and therefore a belongs to image of their union of images. Okay, a belongs to union of images, and this element is a elements of f of x union y, and this is belongs to f of x union f of y, which implies that this set is a subset of this set. Okay, so similarly next part, similarly conversely means to show second condition. Okay, so proof of this theorem, let f of x is subset of, let a belongs to f of x union y, let a belongs to f of x union y, then there exists at least one element, b belongs to x union y, such that f of b is equal to a. Okay, such that f of b is equal to a. Then b belongs to x union y, which implies that b belongs to x or b belongs to y, because here union condition, which implies that b must be belongs to x or y. Okay, means which is common or not common here, but this b is must be belongs to one of the set of x or y. Okay, b belongs to x or b belongs to y. Okay, so if b belongs to x, then here b belongs to x, then f of b belongs to image of f of x is must be belongs to f of x, or f of b belongs to f of image of y. Okay, so f of b is equal to f of x, or f of b belongs to f of y, then which implies that f of b belongs to f of x union f of y. Okay, therefore f of b belongs to f of x union f of y. But f of b is equal to a, which implies that a belongs to f of x union f of y. Okay, and therefore here a is the elements of f of x union y, and this is belongs to in f of x union f of y, which we say that f of x union y is subset of this set. Therefore f of x union y, f of x union y is subset of f of x union f of y. This is the first part. Okay, so here first part is proved. Then conversely means to show that f of x union f of y is a subset of, conversely to show that, what here to show f of x union f of y is subset of f of x union f of x union y. How to prove this is f of x union f of y? Here take any elements from f of x union f of y. Okay, then any element, suppose a belongs to f of x union f of y, then a belongs to f of x or a belongs to f of y. Okay, a belongs to f of x or a belongs to f of y, which implies that this means that a is the image of the some elements in x. A belongs to f of x. The f of x is the image set. F of x is the image set of x. Okay, f of x is the image set of x, and a belongs to f of x. This means that a belongs to f of x. This means that a is the image of the some point in x, some point or some element in x. Okay, means any elements from a is image of some element in x, means there exists at least one b belongs to x, such that f of b is equal to a. Okay, f of b is equal to a means at least one of the element exist in x, such that their image is a. Okay, their image is a, means f of b is equal to a, or if a belongs to f of a, or a belongs to f of a, means a is image of some elements in y. If a belongs to f of a, means a belongs to image set of y, then at least one element exists in y, at least there exists b belongs to y, such that f of b is equal to a. Okay, means at least one of the element exists in y, such that their image is in f of y. Okay, therefore a is therefore a is the image of some point. This means that uh, this two sentence means that a is the image of union of two sets, union of these two sets, elements of union of these two sets. Okay, a is the image of image of elements of union of x union y. Means at least element exist in x or element exist in y, means their union, if their union image is exist in f of x union f of y. Okay, so proof of other part here. Let a belongs to f of x union f of y. Let a belongs to f of x union f of y, which implies that a belongs to f of x, or a belongs to f of y. And there, this means that that is a belongs to f of x, which implies that a belongs to f of x, which implies that a is the image of some point. A is the image of some point in x. Okay, that is there exists b belongs to x such that f of b is equal to a. Okay, that is means at least one of the a is the elements of f of x, means range set of x, then at least one element exists in x such that their image is equal to a, and this a belongs to f of x. Okay, or a belongs to f of y, or a belongs to f of y, which implies that a is the image of some point. A is the image of some point. A is the image of some point in y. If a is the element of range set of image set of y, then there exists here, that is there exists b belongs to y such that f of b is equal to a, means at least one element exists in y such that their image is equal to a, and this is belongs to f of y. That is these two sentence means that which imply that a is image of some point. A is image of some point in x union y, means at least x and y, their union x union y, at least there exists one element in x union y such that is there exists b belongs to x union y such that f of b is equal to a, means at least one of the element is exist in x union y such that their value is in a. Here suppose that any element, okay, b or c or any element, okay, means only here this means that only a has at least one element exist in y. Similarly, only a has at least one element exist in x such that their image is a. There means that your condition is or, which implies that means a is the image of some point in x union y. Okay, a is the image of some point in x union y. X union y is a subset of a. Okay, means domain. So therefore a is the image of some point in a is a image of some point in x union y. That is a belongs to image of x union y. That is a belongs to image of x union y, and therefore Therefore A belongs to f of x union y, and here A is taken from f of x union y, and therefore f of x union f of y, therefore f of x union f of y is subset of f of x union y. This is equation number 2. Okay, therefore this is equation number 1, this is equation number 2. Therefore from 1 and 2, therefore from 1 and 2, f of x union f of y, f of x union f of y is equal to f of x union y. Okay, so this is the proof of our theorem. Okay.